Hello, this lecture will be going over the slip fit male part. This picture of your part. Notice now the first thing you do, notice that everything's in metric units. So you're going to want to convert everything over. Another thing that's new, at least to this class as far as I went on blueprints, you should have seen this in blueprint reading class. You may have seen it in previous projects or maybe even in industry if you're out working. Class of fits. Okay, something that's really common with metric prints. They are used also with inch units, but they just seem to be a little bit more common with metric prints. So the first thing you're going to want to do once you see that is you're going to want to go on and look up in the machiner's handbook what a 60 millimeter H7 class fit is. So you're going to pull out your machiner's handbook, look up fits. I believe it's under limits. Then you go and find the 60 millimeters. I'll give you a little bit of a heads up. The next part that you'll be doing on the lathe, which is a slip fit female, it's a mating part to this. That also has a class fit, so you might want to get that blueprint out and then also jot that number down on that print. More than likely what this is going to be, I do believe it's going to be 60 millimeters plus something and maybe 60 millimeters minus nothing. And then usually what a bore is going to be 60 millimeters minus something and another 60 millimeters minus something. But it all depends on what the class of fit is. But what you want to do is you want to program in that mean dimension. It's going to be a fairly tight tolerance. I'm not sure if it's even 1,000 total. So you want to program that mean dimension. And that follows through with all of these. So 39.75 is a mean dimension here, but not here. It's not 51. So you have to figure out what that mean, what that middle of that road is for that tolerances. So once you got all your numbers figured out, then we can kind of go ahead and go at the program. The program itself for this part's not really all that long. It's actually fairly a short program, but it is a challenging part to make because of the tight tolerances. The other thing that's new to this, similar to the last part that we did with the automatic corner chamfer, we're going to use the automatic chamfer mode for radiuses, which is right in here. So we're going to not program those radiuses that are on the part, namely here, here, here. Now notice you got the break all edges, so that means you have to do something with this. You can put a corner on that. Otherwise, you can also just put maybe a 0.03 chamfer on that. Anywhere from even 0.010 to 0.03 will actually break that chamfer. If it's not noted on the print, you probably don't want to go any larger than this. But you do want to put a little bit of a corner. 10 thousandths isn't that much. A 30 thousandths, you're going to hit that with a file fairly quickly to get 30 thousandths. But by programming it in, it's faster and it's a little bit better. It makes it a little bit better looking part also. So program in those. So if I can go back to our manual, this is on page 51 again. So now it's a little bit easier than when we did the corner rounds, because you had to keep in mind what axis you were doing. The I was in relationship to the Z and the X, and the K was in the Z into the X. Corner rounds a little bit easier maybe. It has a simple R. Okay, it just depends on the positive or negative. So on page 52 they give out their example there. So that first one right here is at that 0.5, which is done right here. Now notice once again that they go below what we normally have been in the past, so they go well below it. And then you just program X 0.5. Now notice there's no G02 or G03 here. It's still a G01 with the R negative because it's moving in the negative direction. It's getting more negative. Okay, that'll put that simple radius in there. So then we go up to Z.5. Okay, now there is no corner or radius there, so we're just going to go right up to our next one, X 0.75, and once again, it's a negative because we're going that way, okay, negative radius. Now we come on inside radius. Okay, so we're going to go to Z -1 inch. Now this time it's a positive because it's going up and the X's are getting more positive. So it is a pretty slick tool. It's recognized by most of your newer CNC machines. It may not be recognized by all machines, but I do believe most of your newer ones are accepted most of these codes. So once again, you're not bouncing back between G02 and G01s, but it is kind of a quick way, at least if you just want to break an edge, to utilize that. So I guess if we go back to our part, I think that about covers the part. Like I said, it's not necessarily a real large, long program. It's just a challenge, a couple new challenges with that corner round, and then also that tight fit. So if you have any questions, please come and see me. Otherwise, good luck. Thank you.